All right, welcome. In the last video that you watched, we looked at confidence interval, but we looked at two key factors. We looked at when you are dealing with sample sizes of 30 or more, and we also looked at when you're dealing with scenarios where the population standard deviation is given. Now, if you've been paying attention, having population standard deviation is actually not very common in real life, right? In real life, you tend not to have that. And so you have to use a sample standard deviation, which is a deviation, deviation that you create from the sample you've collected. And that's more realistic scenario. And so what we're going to do here today is how do you solve questions where you are faced with that kind of scenario? We're going to see how we use the t-test, not the z-test. The t is in table. We're going to use this t-test to solve questions that involve confidence interval. And you see the difference and also the similarities between a t-test and a z-test. All right. So just like the last video, make sure you go into your module and pull out the confidence interval that has to do with small samples and standard deviation unknown, and follow along with me as I solve some of these questions. We're going to try to look at 3 questions. My goal is to look at question 1, look at also question 2, and also look at example 10. So example 1, example 2, and example 10, and then give you a chance to get some credit if you submit them on or before the due date, which is Saturday. All right, so let's look at this question, right? Example 1. It says that a tire manufacturer wishes to investigate the thread life of its tires. So the life, how long those threads on the tire last, right? And the manufacturer sampled 10 tires. And so this is where you begin to see the difference, right? You can see in this case, we have only 10 tires. And you can see it's a small number, right? And then it says a sample of 10 tires driven 50,000 miles revealed a sample's mean of 0.32 of thread remaining with a standard deviation of 0.09. You can see that the standard deviation was brought in under this conversation of the sample. And so this tells us that this standard deviation is a sample standard deviation. You're told to do 2 things. You are told to construct a 95% confidence interval, and then you're now asked that, hey, based on the results, right, would it be reasonable to conclude that the population mean is what? 0.30 inches. Remember, your confidence interval is created with the hope that it contains the population mean. So based on that, if someone says that the mean is 0.30 inches, would that sound like a reasonable statement? Well, we're going to find out. So let's start with what we know, and then we'll go to what we do not know. What we know is that the sample size is 10, because there were only 10 tires that were being sampled. We also know that our sample mean from those 10 tires gave us 0.32 inches, right? And so we're going to do our inches. And then we also know that the standard deviation that we're given is a sample standard deviation, and it's 0.09, right? And so we can go ahead and do that, right? All right, so we have some of that knowledge. So we have our confidence interval to be 0.95, because we're told to construct a 95% confidence interval right here. And so our alpha is given as 1 minus this, and that would be 0.05. We're told to construct a 95% confidence, so we're going to do our margin of error here, right? Because that's what's going to help us in creating our confidence interval. So I'm just going to go here and just make this bigger space, and I know, and so if you remember when we were solving this question a couple of minutes ago, we were solving for z-test, and for z-test we said that we use confidence.num, But this is a question that has to do with a t-test. And so we'll select confidence.t. And so we'll select alpha, we'll select our standard deviation, and then we call it our size. So you can see our answer will now be 0.06. That is our margin of error, right? So it's 0.66 inches. All right. So now we can now find our lower interval as well as our upper interval. And so the process now kind of works the same as what we did, right? So now the same thing. Remember, it was our sample mean plus or minus our margin of error. And so this would be your sample minus your margin of error and your sample mean plus your margin of error. So you can see that our confidence interval will fall between 0.255, right? 2.256 inches and 0.384 inches, right? We have created our margin of error. So we can interpret this result and say that we are 95% confident that the population mean thread life is between 0.26 inches and 0.38 inches. Now, we can use this, right, to be able to answer the second part. So the second part says, would it be reasonable for the manufacturer to conclude that after 50,000 miles, the population mean amount of thread is 0.30 inches? Now, if you look at the answer, right, we said it's between 0.26 and 0.38. What this means is that we're 95% confident that the population mean thread will actually be any number between 0.26 and 0.38, with those two numbers inclusive. And since 0.30 falls within this number, then it's highly possible that this could be the mean or the population mean. And so our conclusion is it would be reasonable because 0.30 inches falls within the 95% confidence interval. So that's how we kind of solve questions involving this. Now, we're going to look at two other scenarios where we have to rethink how we solve questions involving confidence interval. And that's where question 2 plays a huge role. Now, if you look at question 2, it's set a bit different. What you ask is the manager of the Arcadia Mall wants to estimate the mean amount spent in her mall, and she samples 21 student customers, and this is the amount that they spend. And you're told to construct an 8% confidence interval, right, for the population mean, and then they ask you if it's reasonable if the manager, just guesses that the average person in the mall spends $5. Now, let me rephrase this question so it makes sense to you. Imagine if you are the manager of the mall and you want to be able to tell people what the average person spends in your mall. Now, normally, right, you would ask all the companies in the mall to tell you the average amount, right? And you can use that to help you come up with a decent number. But supposing that's a trade secret and they don't want to tell you, well, one way you can go around that would be, well, you can have some of your employees maybe stand by the door or by the gate. And as customers leave the store or leave the mall, you say, hey, can I see your receipt and see how much you spend? If you let us see your receipt, we'll give you a $5 Amazon gift card, something, something enticing. And so in this scenario, let's say we had 21 people decide to give you those numbers. And so when you got those numbers from those people, you can create a confidence interval based on the value they've collected. Now, because it's a small number, 21, we'll see that we'll probably use, or we'll definitely use a t-test. But secondly, we're not giving a standard deviation. So population standard deviation is clearly unknown here, which makes a stronger case for the t-test. So the first thing we're going to do is, okay, and what's the sample size? Now I told you it's 21, but what if you're not giving? Well, if you're not giving, you can easily use the count formula, and that helps you count and tells you how many people you have, which is 21. And then we know that our level of confidence is 98%. We know that that means our alpha is going to be 0.02. Now, we're not giving our sample mean. So that's one thing that we need to find. We're also not giving our standard deviation or sample standard deviation, which we have to find. Now, we have the sample here. So finding sample mean is quite easy, right? It's just going to be the average of all these values. And that tells us what the sample is. So we know that the sample mean is about $49.74. And we can also find the standard deviation. And since we're dealing with a sample, we use our standard deviation.s, which is sample. We can select that. So you can see we're able to find our sample mean, we find our sample standard deviation. Now, this is more like a real scenario. Right? This is something that is very common in real life, right? Where you have to find data yourself, where you have to analyze the data, which we've done, and where we can actually easily find our solution. So to draw a margin of error, or E, this will be equal to confidence, and we'll select T. We do our alpha, we do our standard deviation, and then we do our size. So you can see that's the case. And then we do our lower interval. Start at the small caps. And then we'll do our upper interval. All right. So as always, it's going to be our sample minus margin of error, and our sample plus our margin of error. So now we're told to create our confidence interval, right? So we have done that. And we know that it's going to be $44.93 and $54.56. And we can interpret our results, right? Easily here. We can say that we are 98% confident that the population mean amount spent by customers at the mall or Arcadia Mall is between, we can put the amounts there, right? Because it's between 44.393 and 54.56. Right. So now that we've kind of done everything, we just have one thing left. Now the question is it reasonable for the manager to conclude that the mean amount spent by customer at the mall was $65? That's really wishful thinking, right? Because we're 98% confident that it falls within this amount, which is way below what the manager is saying. So it's not, right? It's not reasonable. The manager to conclude that the mean amount spent by customers is $65 because that amount is outside the 90% confidence. All right, let's do one more. And I think question 10 allows us to look at this question from another perspective, because what we want to do is, how do we solve this question from various perspectives? So look at this question. It says, Warren County Telephone Company claims in its annual report that the typical customer spends $60 per month on local and long distance services, right? So to be able to prove this, right, a sample of 12 subscribers reviewed the following. And so this is what you have. And so you're asked to do a couple of things, right? The first thing you're asked to do is to find a point estimate. Then it says you find 90% confidence interval. And then it's now asking you, is that $60 the company claims? Is that a reasonable statement? So let's do that. Now, the first thing we need to do is, what is a point estimate? Now, just like the word says, right, point estimate. A point estimate of a population mean basically tells you that in a scenario where you cannot find the population parameter, the point estimate is the value that helps you do that, right? It's the nearest value in order to find the population parameter. And so in most cases, in almost every case, your point estimate is a representative, or stands for your statistic. So it's descriptive, not only statistical, but a numerical description of the sample that helps you give you an idea of the population parameter. That is the role of the sample mean. Because remember, the sample mean is a statistic. It's a description, a value that describes the sample, but it helps you, gives you an idea of what the population parameter is, which is the population mean. So when you're asked to find the point estimate in a scenario, what they're asking you to do is to find the sample mean, because that's the value that we use to help us create a confidence interval where we have some level of confidence that the population parameter, or in this case, the population mean, is contained in. And so this is just saying you should find the average of these values. That's 3. Now here's asking you to develop a confidence interval. So this one uses all what we've learned so far, right? So we can say, let's count the number of values here. And so the sample size is 12. We can say our confidence interval is 0.9. And so we know that our alpha, which you notice, right? Every time I do alpha, I don't just type in 0.1. I show you in Excel how you subtract and you get 0.1, right? And our sample mean, we don't have to calculate that because we already did it prior, and we got our 63, right? One other thing I also want to do is I want to check and see if there is, you see, that's why it's always good to do that, because you can see that when we do it in 2 decimal places, we find that it's not actually 63. And so that's very important. So I'm just going to go here and I'm going to choose that value. Okay, maybe we can do that here too. All right. And so our sample standard deviation will be equal to our standard deviation. We'll select our S for sample, and then we'll select these values. And so we have our values here, right? And we know that since we don't have a population mean and our sample size is less than 12, less than 30, we know that we're going to use a t-stat. So that'll be equal to, we do our confidence, T, we'll select our alpha, we'll select our standard deviation, and we'll select our size. And so our margin of error is $2.04. And so we're going to do a lower interval. And so for our lower interval, it's going to be our sample mean minus margin of error. And for upper, our sample mean plus margin of error. As always, right? You remember you have to interpret the results. So we're going to interpret the results. So we are 90% confident that the population mean is between 60 and 54 cents and 64 and 3 cents. So let's go back to the third question, which is the key one. Is the company's claim that the typical customer spends $6 per month reasonable? Justify your answer. All right, now that's a good question. So let's look at our answer. Our answer says it's between what? 60.54 or 54 cents and $64.63. So this is what? Not reasonable. Right? It's not reasonable because what the company is saying is not correct. At 90% confidence, we can see that a typical customer would spend probably between $60.54 and $64.63. All right? Because at 98% confidence interval level, typical customer will probably spend a value, a number between 60.54 cents and 64.3 cents. Put numbers. Right? So at 98% confidence, we're seeing that the company is probably being a little bit conservative, right, in its value, saying, hey, the customers spend about $60, but what we found is slightly more than that, at least 54 cents more than that, right? And so that's how you solve questions involving confidence interval when you don't have population standard deviation given or when it's unknown, and when you have values that are less than 30. Now, based on this, right, what I want you to try for extra credit for this week is questions 3 and question 9. Both questions are good questions that test your understanding of the concepts. And I hope that you are able to try these ones and see how good you are with confidence interval. And I hope this video was helpful as you move forward in the class. Thank you, and see you all next week.